Let's take a look at a couple more application problems involving exponential models and the use of logarithms. Okay, so our first one, India had a population in 2008 of 1.14 billion people. Population is growing by 1.34% each year. If the trend continues, when will the population reach 1.2 billion? All right, well, we know this is exponential growth because it's a consistent rate or percent of change. And so I'm going to use the general model. P sub n is equal to 1.14, the initial, times 1.0134 raised to the n. Remember that inside thing that's being raised to the exponent is 1 plus the growth rate, the growth percentage. If it'd be decreasing, we'd subtract. All right, so that's our general formula. They want to know when is that going to equal 1.2. So we're finding the n, they're giving me the p. So here's my equation to solve. 1.2 equals 1.14 times the quantity 1.0134 to the n. Our four-step process to solve for that n, we can't divide it away. It's exponents are not multiplication. It's a little different. So first thing is I'm going to isolate that number that's being raised to a power. So we're going to divide the 1.14 on both sides. And we're not going to worry about that left-hand side. We're not going to simplify or try to get a decimal answer that's rounded. We don't want to introduce any error, so just leave the messy fraction at this point. Once you've isolated, then you're going to take the log of both sides and apply the power rule. Okay, so I just stick log in front of both sides, and then the power rule says you're going to take the exponent n and bring it out front so that the equation looks like this. Log of the 1.2 divided by 1.14 equal to n times the log of 1.0134. So that exponent now becomes a multiplier to my log. Well, if I'm solving for n, then that means I would divide to get it by itself. So we'll divide both sides through by the log of 1.0134. You want to use your calculator here, right? And then I'm going to get approximately 3.9. Well, that's not the answer. They were asking for what year. What year would we have this? 3.9 is not a year. It's 3.9 years since or after 2008. So we're going to add that to 2008. I'm going to call it 4, which would land me at 2012. Let's take a look at another. This one's going to require a little bit more work ahead of time. So it says a native wolf species has been reintroduced into a national forest. Originally, there were 200 wolves transplanted. After 3 years, the population had grown to 270 wolves. So we're going to assume that the population grows exponentially, and they want us to write an explicit formula. Well, the explicit formula means take the initial amount times 1 plus whatever my growth rate is raised to the n power. Well, I don't have the growth rate. They didn't tell me that. But what they did tell me is what happens in 3 years. They told me what p sub 3 is. So I can plug in p sub 3 and 3 for the n and then try to solve for r. So I'm going to solve the equation 270 equals 200, the initial amount, times the 1 plus r raised to the third. If I'm trying to get to the r, first thing I need to get rid of is that 200 times that parenthesis stuff. So we'll divide both sides by 200. Okay, so now I've still got my r trapped inside a parenthesis that's raised to the third power. That means we want to take the cube root of both sides. On the right hand side, that cancels out that exponent, and on the left hand side I just have the cube root of whatever the cube root of 1.35 is. I'm not going to worry about that at this moment because I have one more step in order to find in order to find r. I need to subtract the 1 from both sides. So on my calculator I would take the cube root of 1.35, then subtract 1, then my last step would be to round. In this case, I'm going to get 0.105 is approximately what R is. So that's about 10.5%. That's a pretty decent growth rate. So in general, we would come up with this formula for P sub n. P sub n is equal to 200 times the quantity 1.105 to the n. All right, so we found our R. Now it says write the recursive formula. Well, if you recall, recursive formula means you give me a value and then you tell me how to get the one right after that. So in this case, we know that P sub n is equal to 1 plus R times P sub n minus 1. So we're using exponential. So P sub n is going to be 1.105 times P to the n minus 1. So whatever your starting one is, you're going to multiply 1.105 times that, get to the next one. Then you multiply it again by 1.105 to get to the next one after that, and so on. All right, let's make it a little bit more complicated. So here's our general explicit formula for this problem. And then it says, if the trend continues, how many wolves will there be in 10 years? So they're asking for the population, the P, and they're telling me what place in the sequence it is. It's 10 years out. So really this just means plug in a 10 for the n. And I'm going to use my calculator to do that. 200 times 1.105 raised to the 10th is approximately 543 wolves. Okay, that's a pretty straightforward one. This one is where it starts to get messy and require a little more algebra. It says, if the trend continues, how long will it take the population to grow to 1,000 wolves? So this time what they've given me is the P answer, and I'm supposed to figure out what the n is. The only way I'm going to do that algebraically with a precise answer is to use some logarithms. So the first step is to isolate my exponential. I divide both sides through by 200. Then I'm going to take the log of both sides. Then I'm going to say, well, wait a minute, I have log of something to a power. The power rule says that exponent comes out front. So now I have log of 500 equals n times the log of 1.105. So to get n by itself, I would divide both sides and I would get approximately 62. So what was my first year? Well, go back and look at your problem. It doesn't really tell me, so I'm just going to say my answer here would be, well, in about 62 years, you will have a population of 1,000 wolves if this model holds. Let me know if you have any questions.